Here is the part 1 of the domain and range series, because we are going to have 3 videos specifically for this topic. In the last video we went through this process. So first of all we are going to choose the input, and then we plug it into the function, and then we calculate through the function, and then we are going to produce an output for us. So the set of x values, the input, is called the domain, and the set of f of x values or the y values, or the output, is called the range. Now in general, we have two types of domain here. We have natural domain and we have restricted domain. So what exactly is the difference between those two? Well, an example of a restricted domain is here. Now you can see that in this graph here is a linear graph, it's a linear function. Because it's a one-to-one mapping, it's a one-to-one function. So we could have had all values of x. But instead, we are going to restrict it so that x is less than 4. So this is a type of restricted domain because we only want to select x is less than 4. We don't want x is more than or equal to 4, so that is out for us. So let's say if we plug it in x is equal to 6, you won't get an answer, you won't get an output. The result is undefined. Yeah, it's that simple. So when we have a restricted domain, we are going to have a restricted output. So of course we are going to have a restricted graph. So when x is more than or equal to 4, you won't see any graphs at all, any points at all, because there's no values of y that we are going to get when x is more than or equal to 4. So it's a complete blank for the graph after that. So this graph here is a small part of what could have been a very long graph. So this is a restricted domain, and this, as you can see the graph here, f of x is more than or equal to 7. This is also a restricted range because there's a restricted domain going on. So you can see when there's a restricted domain, when there's a restricted range, we can find a restricted range and restricted domain respectively. So how are we going to find that? So let's go through this example. X is less than 4, f of x is equal to 2x minus 5. So as you can see, as x is decreasing onto 0, onto negative infinity, the y values will go down and down and down until it goes to negative infinity. Now, by the way, infinity is just a concept, it is not a number, because it is used to describe those very large or very small number that we can't even describe it. Yeah, so infinity is just a concept, don't take it as a number. So y values will go down until it reaches negative infinity. So the lowest point will be negative infinity, it is unseeable, and then the highest point, if you look at the graph, it will be at when x is equal to 4, isn't it? When x is equal to 4, we will get the highest point of the graph. So let's calculate when x is equal to 4, what is the output that we are going to get. So f of 4 is equal to 2 multiplied by 4 minus 5, which is equal to 3. So at this value, when x is equal to 4, we are going to have 3. So in conclusion, our range is f of x is less than 3. And that is it. We can't get any values of output more than or equal to 3. Now let's see another example. It's the same function, but we are going to change the domain now. Now you can see it is x is in between 2 and negative 1. So this is the graph that we are going to get. It's smaller because the domain is so much more smaller. So you can see the highest point here for the f of x is when x is equal to 2, and the lowest point is when x is equal to negative 1. There's no such thing about infinity or negative infinity anymore in this case. So we are going to find the values of f of x equal to f of 2, which is 2 multiplied by 2 minus 5, and that's negative 1. And then also f of negative 1 is equal to 2 multiplied by negative 1 minus 5, and that's negative 7. So we're just gonna write down. So this will be negative 1, and this will be negative 7. So in conclusion, in between negative 7 and negative 1, we include the negative 1 because when x is equal to 2, it is included in the function, whereas x is equal to negative 1, it is not included in the function. It will be a result of undefined. Yep, so this is the final range that we are going to get. Now what about something like this? This is a cubic graph. f of x is equal to x cubed minus 5, and we are going to restrict the domain such that x is more than 1. So you can see that the cubic graph, the output is going to go up to infinity. So does when x is also going to infinity, on a positive infinity. So the lowest point will be when x is equal to 1, and the highest point will be when x is very, very large, and f of x is going to be very, very large, up to positive infinity. So we are just going to find f of 1 value. So that will be 1 cubed minus 5. So that is negative 4. So our range will be f of x is more than negative 4. This value here is negative 4. Yeah, so that is it. X is equal to 1 is not included in the function. We are not going to include x is equal to 1, so it will be a result of undefined. So f of x cannot be equal to negative 4. We can't get that value, but it is more than negative 4 only. Yeah, so let's see here. This is a quadratic graph, and we are going to restrict it so that x is in between negative 3 and 1. Now you can see that the highest point here is when x is equal to negative 3, and the lowest point is not when x is equal to 1, it is when x is equal to 0. You can see the graph here is going down, and it moves up again. So now we are going to find the values of f of negative 3, and that's 2 multiplied by negative 3 squared, and that is 18. And f of 0 is 0, basically. So our range would be in between 0 and 18. Yep. So that is the range for the quadratic graph. So we must make sure that we know the shape of the graph, because you can see in the last 3 examples, it seems like we're just going to substitute all these critical values here. Whereas in this case, x is equal to 1 is not the lowest point, so we don't use x is equal to 1 to find the range of the graph. We instead use x is equal to 0 because that is the lowest point of the graph. Talking about how the shape of the graph is important, let's see the final example of finding the range here. Now in this case, we are not going to restrict any domain at all. We are going to have all values of x because x is an element of real numbers. This sign here is called is an element of. So we can have all values of x, but what exactly is the range of this function? This is a quadratic curve, so there must be a minimum point or a maximum point. Since the coefficient of x squared is positive, it is a U shape, so that will be a minimum point. It is this coordinate here. X is equal to 3 over 4, y is also equal to 3 over 4. So the minimum point is this. So I skipped all the steps for completing a square. Yeah. So f of x is bigger than or equal to 3 over 4 for this y coordinate up to positive infinity, because you can see it's all going up to positive infinity. Just now we were finding all about range when there's a restricted domain or even when there's a natural domain in the last example there. Now we are going to find the opposite one. We are going to find the restricted domain when we are given the range. So as you can see here, there are 3 graphs, 2 of which are linear function and 1 of them is a quadratic function. So in the first example, it's actually the same as the first 2 examples, 2x minus 5. Now f of x is more than or equal to 7, so let's just write down actually f of x is more than or equal to 7. So 2x minus 5 is more than or equal to 7. So we're just going to add 5 to both sides. So 2x is more than or equal to 12, x is more than or equal to 6. Yep, so the restricted domain is x or more than or equal to 6. So this is 6, all the way up to positive infinity. So in the second example, it's a much shorter line. It's in between negative 11 and negative 4 for the f of x. So that means negative 11 is smaller, 2x minus 5, negative 4. Correct, right? We are just going to substitute 2x minus 5 into f of x. Now we're just going to add 5 to both sides. Yeah, negative 11 plus 5 is negative 6, smaller than 2x, smaller than or equal to negative 4 plus 5, 1. So we're just going to divide by 2. So this will be negative 3, smaller than x, smaller than or equal to 1 over 2. So this will be the restricted domain. That means here the highest point of the graph is when x is equal to half, and the lowest point is when x is equal to negative 3. Yeah, so that's how you find restricted domain for a linear function. Now what about a quadratic one? So f of x is more than equal to, f of x is more than 7. You can see that there's two x critical values that we need to find. So we're just going to find that. So for x squared minus 6x plus 3 is more than 7. Just going to minus 7 on both sides. For x squared minus 6x, 3 minus 7 is negative 4, more than 0. We can factorize out 2. Yeah, 2. So that's 2x squared minus 3x minus 2 is more than equal to, is more than 0. Can we factorize that? I think we can. Minus 2 plus 1. Yeah, looks good. So that means one of them, it is 2, and the other is negative half. So it is less than x is less than negative half, and x is more than 2. So in conclusion, we'll have x is smaller than negative half, x is more than 2. So that's the restricted domain for this particular function where f of x is more than 7. So in the next video, we are going to talk about natural domain more, because this is all about restricted domain except the last example about finding the range, that one. So for natural domain, we can't square root a negative value, and we cannot divide by 0. So there's a certain restrictions to specifically for some functions. So once again, we are going to look at lots and lots of examples about natural domain and how do we find the range, how do we find the domain. So stay tuned for that. Actually, I realized something after I made the video, is that when you flip the graph, it becomes a Nike.